Hello guys, welcome back. Good to see you in part two. So in this video, this will be like a continuation to the previous part one of this question. This question is LC-91 decode ways, and in part one we did the like the naive solution for this one, which is a recursive solution, not so naive. But this is an exponential solution, and once you submit it, this one we got a TLE. So in this one, we'll discuss how we can optimize it and pass all the 269 test cases on lead code and feel happy about it. Okay, so this is going to be fun. Let's do it. Okay, so basically what is happening is why it is giving me a TLE is because the time complexity is very bad, right? It is going exponential and I need to optimize it. Now in these type of questions, what we need to do is that any repetitive calls that we are making, we need to store their answer and then refer to those to save my computation. So anything that I have computed before, I don't want to do it again. I want to save my time and energy, and I want to use that computation and then proceed with solving the question, right? So basically, what you will need is that you need to store your output. So what I'm going to do is I'm going to create a DP array. I'm going to name it DP, and this is what is going to act as the storage for me, which where I will store my solution and then refer to it to get the answer, right? Now in this, I will make uh, it of size s dot length, because my string length till my string length I need to store the computation or the decoding for every character which it is passing through, right? So that is why s dot length. And what I'll do is I'll pass it to my function. Also, before that, before we proceeded, we don't have to forget about initializing this. So since the possible decoding is always a positive integer, so what I'll do is I'll do the initialization, which is a negative number. So I'll initialize it with -1. Okay. Now what I need to do is I need to correct this function to update it. And now I need to use this DP array in my recursive solution. So this part is easy. This part is not difficult. Actually, understanding the first part is what is the difficult part. This part is easy. So what will happen now is that before doing any further computation, I will check that is my answer stored in my DP. So I'll say that if dpi is not equal to -1, that means I've computed it already and I've done this computation. So I'll do return dpi, don't do any further computation. Else, what I'll do is that, okay, you get me do all the computation because it's a new, fresh decoding that I'm doing. But in the end, I'm also storing it in my DPI, right? This is all that I need to do. And apart from this, I also need to pass it here. Otherwise, it will say parameters were expected here and you have not passed it, which is not good. So int I, S, and DP, you've passed it here. You have stored your result in your DP index, then you have returned it, you have made the check, you have initialized your DP array with -1. So I think this should be good. Let's try running it. All right, stupid mistake. I have to do this and also actually use this test case to see if we pass this one. All right, great. It got accepted, and the one that we were getting TLA is now giving us the answer. Let's submit it. All right. So the solution is accepted. Congratulations. And it beats 100% of your users in Java, which is good. So yeah, this is how the solution for this one would look like. The time complexity of this would be linear O of n. Obviously, we'll be, since we are using extra space, so we have now have a space complexity also, an extra storage space of on. And that is all. Congratulations, guys. See you in some other questions some other day. Bye.